Something unusual has been happening at Tesla's Giga Texas facility. There are covered prototypes, restricted testing areas, and quiet upgrades to the production line. It feels like Tesla is hiding something major in plain sight. This is Tesla Global. Let's get into it. Now, a series of new leaks might have revealed exactly what that is. A completely new 4680 Gen 2 battery, not designed for the Cybertruck or Semi, but specifically engineered to power the highly anticipated and affordable Model 2. Elon Musk recently said, "Our biggest constraint this year is battery packs, but we're working to solve that. I think we'll make significant progress on this issue, and next year things will really take off." That statement, when you connect it to the recent developments at Giga Texas, makes the situation even more intriguing. This isn't just a slightly improved version of what's inside the Cybertruck or the Model Y. Gen 2 is smaller, cooler running, cheaper to make, and may just be the key to unlocking a truly mass-market $10,000 EV without sacrificing performance. In today's video, we're breaking down everything you need to know. How 4680 Gen 2 actually differs from Gen 1, why the new cell size might matter more than you think, as well as what it means for charging, cooling, and price. If this is your kind of deep dive, hit subscribe to Tesla Global, as we're almost at 11,000 subscribers and your support really helps us keep going. Turn on that bell too, because the next reveal might be even bigger. Now, let's get into it. 1. Why did Tesla ditch its 4680 flagship battery for something new? According to multiple industry insiders, the upcoming Model 2, Tesla's long-rumored $10,000 electric car, will not use the standard 4680 battery cells currently powering the Cybertruck and select Model Ys. Instead, Tesla is preparing to launch a next-generation version, 4680 Gen 2. Although revolutionary when first introduced, the 4680 Gen 1 battery has faced three critical limitations that made it unsuitable for compact mass-market vehicles like the Model 2. Second, there's the issue of size. The large 46mm diameter and 80mm length of Gen 1 cells work well for trucks and SUVs, but are too bulky for smaller EV frames. Gen 2 reportedly reduces overall cell volume by up to 30%, with new form factors better suited for compact platforms without sacrificing energy density. Third, thermal management has been a problem. Generation 1's structural battery pack design presented cooling challenges, especially under high loads or rapid charging. What makes the 4680 Gen 2 even more revolutionary is Tesla's integration of a solid liquid hybrid electrolyte, a breakthrough chemistry that significantly lowers internal resistance while minimizing heat during high-speed charging. Unlike traditional liquid systems, this hybrid approach offers greater thermal stability and safety while enabling faster ion mobility, a critical factor for next-gen superchargers. Even more promising is Tesla's development of a self-repairing electrolyte system designed to automatically heal micro cracks and prevent lithium plating, two major causes of battery degradation over time. By using a manganese-doped silicon anode paired with a flexible gel-based electrolyte, the battery can redistribute ion flow during idle periods, maintaining uniform chemistry across thousands of charge cycles. Generation 1 had promise, but Generation 2 might finally deliver. If you think Tesla could crack the code, drop a 4680 Gen 2 if you're on board. 2. How did Tesla disguise a revolution as just another battery? Tesla's next-generation battery, the 4680 Gen 2, includes key changes across chemistry, cost, cooling, form factor, and performance. Each one is carefully tailored, not for flagship vehicles like the Cybertruck or Model S Plaid, but for the long-awaited mass-market Model 2. While the original 4680 Gen 1 uses a high-nickel NCM chemistry optimized for performance and long range, Gen 2 reportedly adopts a lithium iron phosphate silicon hybrid blend. Though traditionally it has lower energy density, Tesla's solution is to incorporate a silicon-doped anode, boosting specific energy while preserving LFP's long lifespan. As a result, Gen 2 energy density lands at around 220 watt-hours per kilogram, slightly lower than Gen 1's 272 watt-hours per kilogram, but with benefits that far outweigh the trade-off for a compact vehicle. Cost is where the difference becomes staggering. Gen 1 cells cost an estimated $120 to $140 per kilowatt-hour. Gen 2, however, is reportedly pushing that number down to between $60 and $70 per kilowatt-hour, nearly a 50% reduction. One of the most significant physical changes lies in the cell dimensions. While Gen 1 measures 46 by 80 millimeters, Gen 2 shrinks the length down to 70 millimeters. This seemingly minor 10-millimeter reduction has major ripple effects throughout vehicle design and manufacturing. Thermally, the shorter cell reduces internal electrical resistance, cutting heat buildup during high current loads. This allows Tesla to abandon the complex liquid cooling loops found in Gen 1 systems in favor of air-based or thermal pad cooling, significantly lowering both weight and cost. From a mechanical perspective, smaller cells are easier to fit into tight chassis designs. For the compact Model 2, every millimeter counts in battery pack packaging. This change alone could shave centimeters off the battery pack's height, reducing the car's center of gravity and improving road feel, handling, and crash safety, especially important in smaller, lighter vehicles. Manufacturing also stands to benefit from the smaller cell size. Shorter cells experience less mechanical stress during production processes like jelly roll insertion and tab welding. All of this adds up to a major change in strategy. Tesla is not just cutting battery costs, it's also making their batteries smarter. The 10-millimeter reduction from Gen 1 to Gen 2 is not just a small tweak, it's a sign that Tesla is updating its manufacturing methods to reach the global mass market. So, what makes the Model 2's battery architecture so game-changing? Tesla's Model 2 is set to introduce a battery design that could completely change the way electric vehicles are built and scaled around the world. At the center of this shift is what many insiders are calling Structural Battery Pack 2.0. Instead of treating the battery as a separate part, Tesla is making it a key part of the car's chassis itself. By building the pack right into the frame, they can remove extra materials like crossbeams and support brackets, reportedly cutting overall vehicle weight by as much as 20% and boosting both efficiency and handling. Another major change is the switch to a cell-to-pack setup. This means skipping the traditional step of building cells into modules before making a battery pack. Instead, Tesla installs the cells directly into the battery enclosure. Leaked specs suggest that the battery will have a capacity of between 50 and 55 kilowatt-hours, delivering a real-world range of around 210 miles per charge. The entire pack is expected to weigh approximately 330 pounds, which is about 40% lighter than the battery used in the Model 3. That weight reduction is significant. It translates directly into lower energy consumption per mile, better acceleration, and lower production costs. The cooling system is another area of major innovation. Instead of using liquid coolant tubes and complex channeling, Tesla appears to be using a combination of airflow design and embedded thermal pads to dissipate heat across the pack. This removes bulky fluid-based systems and allows the pack to remain slimmer and easier to integrate into the vehicle floor. Lastly, the Gen 2 battery pack in Model 2 is designed from the ground up with full vehicle-to-grid functionality in mind, not as an afterthought but as a core feature. At the heart of this capability is a new modular pack architecture where individual cell groups can be monitored and controlled independently through advanced battery management systems. This allows for precise power flow regulation, making bi-directional charging both safe and efficient. Combined with integrated bi-directional inverters and Tesla's native energy software, the Model 2 can seamlessly return electricity to homes or the grid when demand peaks, turning each vehicle into a mobile energy hub. Thanks to the LFP chemistry, which is more thermally stable and cycle-resistant than traditional nickel-based batteries, the battery can withstand thousands of charge-discharge cycles with minimal degradation, which is essential for daily V2G use. Together, these features enable a future where millions of EVs, like the Model 2, don't just consume energy, but actively stabilize and support the energy grid. In doing so, Tesla isn't just redesigning batteries, it's redefining the role of electric vehicles in the global energy ecosystem. Do you think this 4680 Gen 2 battery design gives Tesla an unbeatable edge? Comment, Tesla wins, if you believe they've just changed the EV game. One major factor is drivetrain simplification. Instead of dual-motor all-wheel drive, the Model 2 is expected to use a single rear-wheel drive motor. This alone eliminates a second motor, inverter, and complex wiring systems, cutting drivetrain costs by up to 40%. Tesla's skateboard-style platform with a structural battery removes traditional frame components like rails and cross-arms, saving an estimated $1,000 to $1,500 per unit in materials and labor. Combined with gigacasting, which molds entire sections of the vehicle in one piece, body assembly costs could be reduced by another 30 to 40%. Tesla's in-house semiconductor strategy also plays a key role. In the Model 3, more than 100 third-party chips are used across various control units. For the Model 2, Tesla is expected to consolidate over 70% of these into custom systems on chip, potentially bringing the total number of chips down to under 30. All of these efficiencies, from drivetrain to electronics to manufacturing, combine to cut total production cost by at least $8,000 to $10,000 per vehicle compared to current EVs. That is how Tesla plans to offer the Model 2 at an unprecedented price point while still aiming for profitability at scale. The Tesla Model 2 is designed to deliver practical performance without compromising affordability. It accelerates from 0 to 60 miles per hour in just 6.7 seconds. While that is not in the realm of Tesla's high-end models, it is still faster than most economy-class gas cars, making it more than capable for everyday driving. On top of that, with fast charging capabilities allowing 10 to 80% top-ups in approximately 25 minutes, the Model 2 directly addresses one of the final hurdles for EV adoption, reducing wait times at public chargers to a level consumers can accept. Underneath that user-friendly experience lies Tesla's most aggressive cost-cutting strategy to date. Centered around the new 4680 Gen 2 battery, this cell design reduces per kilowatt-hour costs by nearly 50% through simplified materials, faster production lines, and optimized form factor. Tesla's structural battery pack replaces traditional vehicle frames by integrating the battery into the chassis itself. In addition, the use of LFP or lithium iron phosphate chemistry instead of more expensive nickel or cobalt-based formulations further reduces cost, while improving safety and long-term durability. Every technical decision, from chemistry to manufacturing location, serves a single purpose: to make clean electric transportation truly accessible on a global scale. So is this the battery that changes everything, or just the best sales pitch Tesla has ever written? This could be the moment Tesla flips the entire auto industry with a battery so cheap, so scalable, it makes gas cars and old factories obsolete overnight. The future isn't coming, it's already being built.